Recreational Astronomy Night Meeting of the Toronto Centre RASC. I'm Paul Markov, and I'll be your host for this evening. We are at the Ontario Science Centre. We have about 15 people here with us tonight. To our online viewers, a reminder that meetings have resumed at the Ontario Science Centre, so next time perhaps you can join us here in person. Now, for those who definitely cannot make it in person, we will continue broadcasting the meetings over YouTube as usual. And that's because we have a great audiovisual team here who sets all this up for us. And that's Andrew and Betty Reed. And we have Ward LeGros here. We're missing a couple of folks tonight, but typically they help us out. That's Ennio Cilucci and Reza Mohammed as well. As you know, I'm always on the lookout for presentations. I'm glad to say that the September meeting is full. We have openings for the October 4 meetings and later. A reminder that our meetings happen on the first Wednesday of each month. We have 3 presentations for you this evening as usual. Claudio Oriani will present the sky this month. Followed by Ralph Chou, and he'll tell us about his visit to the Perth Observatory in Australia. And then Frank Dempsey will talk to us about forecasting the location of wildfire smoke in relation to observing, of course. So Tom Luton, our president, will wrap up the meeting with the announcements, and we should be done by about 9:30, perhaps a bit earlier. If you're watching us online and have a question for our speakers, please enter it in the YouTube chat box, and Ward will ask the question on your behalf to the speaker. For in-room questions, put up your hand and I'll come over with a microphone. Please wait for the microphone so people online can hear your question. And do we have anybody here for the first time, whether you're a member or not? It doesn't matter. Show of hands, anybody here for the first time? Very good. Welcome. Hope to see you next time as well. And if we have somebody who's joining us online for the first time, please let us know as well through the chat box. And I think we're ready to go with Claudio and the sky this month.
Thank you, Paul. Hi, everyone. My name is Claudio, member of the Royal Astronomical Society of Canada, Toronto Centre since 2018, I believe. And today I'm going to talk about the sky, the month of August and September. It's warm outside, so whenever it's clear, go out and look at the sky. It's beautiful. Highlights for this month. So we have a few events, but I want to focus on a few of them. So August 10, Mercury will reach the greatest eastern elongation. It's not that good for the northern observer. Unfortunately, it's only good for the southern observer. I will go more in detail. But on August 12, 13, but for the entire month, there will be the Perth meteor shower, and go out if you can and watch this beautiful. There is no moon around, so perfect. Antares will be occulted by moon on August 25th, and Saturn will reach opposition. We are reaching the planet season for this year, so Jupiter will join later, and we have 2 super full moon. I don't like, but you know, clickbait. We had a super moon yesterday, and we have another super moon. More than that is a super full blue moon, the end of August. And the beginning of September, there is a chance to see the zodiacal light for a couple of weeks before morning twilight. Planets. So as I said, Mercury, it's technically visible in the evening, but is not that bright. So its magnitude is around 0.2. There is a moon that can help in a few days. Venus will disappear, but it will appear the second half of August in the morning. It will be very bright. Mars, it's hard to see and very small in diameter. Jupiter will be out for the second half of the night. Saturn will be available for the entire night. I watched Saturn a couple of nights ago. It was beautiful. Uranus and Neptune, who has a telescope, can try to find them with a map. And I will show you in a few minutes. There's so many events. I don't want to go all around of these events, but as I say, Venus will disappear, but highlight a few dates. So Perseid, Mercury, Saturn, plus a few events. The moon is occulting a couple of stars that are bright enough. So let's start with how many hours of dark sky we have to observe. So August 2nd tonight, we have 14 hours and 32 minutes of daylight. That means that we only have 5 hours and 30 minutes of darkness between 10:30 and 4 a.m. But by September 6th, when the next meeting will be here, we have reached 1 hour and 4 minutes more dark sky. So that's good. 7 hours, 41 minutes of darkness. That's good news for astronomers. And let's go to the sun. The sun is approaching X maximum. So please don't never look directly at the sun. So you need special filters and certified solar eclipse glasses or telescope solar filters or special telescopes. This picture, by the way, has been taken by my friend Jeff a few days ago, and there are so many sunspots and also prominences. So I know that someone here has an hydrogen alpha telescope and is sharing pictures that are beautiful. Let's go with the moon. So today the moon is very close. I don't know if you can hear. The tide is very high, but at the end of August, it's even closer, by probably 200 kilometers closer. And these are the phases of the moon. So the last quarter will be on August 8. A new moon, good news for astronomers again, it's going to be on August 16, and that's very good for the Perseid meteor shower, because the moon is not disturbing too much. And then I want to go to the next full moon, a blue moon. The blue moon is the second full moon of the month. Actually, I discovered that the real blue moon is the 4th full moon consecutive, but they decided that blue moon, it's easy to remember when the second full moon in the same month. And on average, the moon, when it's very close, is 16% brighter and 8% larger from Earth. I'd never noticed that before. Maybe I can take picture and see if they can spot any differences. Some events, these I discovered a few days ago from my friend Chris Vaughan in the Skylights. So on August 4th, 1:10 a.m. to 2:48 a.m., that's an interesting occultation of the moon. There is a triple star in Aquarius, see Aquarius. The two of these stars will be occulted by the moon. And this will happen in Toronto. I made this screenshot from Stellarium from Toronto. So this will happen at 1:10 a.m. The first star will disappear on the northern side of the moon, and the second star will disappear a little bit after, and then will appear again. The fact that the moon has no atmosphere, the stars will just disappear instantaneously. There will be no dim of the light. And another event, always visible from here, but it's a little bit more challenging, it's the occultation of Antares in Scorpio on August 24. I'm telling that because the moon will be very low to the horizon, and when the Antares will reappear on the other side of the moon will be only 0.5 degrees above the horizon. So probably it's pretty much impossible to see from here. But try and let me know if you can. And now the highlight of the season, the Perseid meteor shower. I want to spend some minutes here. Actually, they are active between mid-July and August 25th. But the peak is usually on the nights of August 12th, 13th. And you have to be up between midnight and 5 a.m. to have more chances to see them. The maximum zenithal hourly rate is 150 meter per hour, but this is something that is ideally visible from a dark sky. From the city, probably you will never see 100 meters, maybe less. So suggestion for you is one, find a dark location. You don't need a telescope because they will be spread all over the places from a radiant, I will show in the next slide. And don't look directly in the direction of the radiant. It's like when you go with a car and it's raining, you see the rain coming from the window, but you see more drops of rain on the sides. And be patient. You don't go out and spot a meteor after 1 minute. So you also have to adapt your eyes at least 20 minutes to the dark. Don't look at your phone, and have a nice and comfortable chair. Zero gravity chair are perfect for that, unless you're falling asleep, and also a blanket if it's cold outside. So that's the picture, the screenshot from Stellarium. And as you see, number one is the constellation Cassiopeia that is rising around, actually is never rising because it's circumpolar from our latitude, but you see high in the sky this W constellation around midnight, even higher and higher. Another bright star you can spot is Capella on the bottom, number 2, and this year will be joined by Jupiter, number 3, and number 4 is around the constellation of Perseus. That's why the name Perseids. And there is a double cluster, H and Key Perseid. This is the direction from where the meteors are apparently moving. And this is the place you have to look, but look around to the right, to the left, to the top, and to the bottom, and be patient. There will be prizes. Let's go to the planets now. So, as I said, Mercury in August has the best opportunity in 2023 to be spotted from the southern hemisphere, not from here. And from the northern hemisphere, the magnitude is plus 0.39. So when there is still light from the sunset, never look at Mercury when the sun is still up because they're very close. I told you. And the altitude in this image is just 5 degrees. Let's go to Venus. Venus disappeared in the first half of August, and it will be visible after August 15. Inferior conjunction means that the Sun, Venus, and the Earth are aligned, so you can't see Venus. And then Venus will appear at dawn, before dawn, the second half of August. It will be very bright. Let's go to Mars. Mars is also very dim in the sky. It's technically still possible to see Mars in the evening twilight in August, but it's hard to be spotted. Maybe you have a chance on August 18 because the Moon and Mars are very close. So if you see the Moon after sunset, when the sky is dark enough, you can see the thin crescent Moon and Mars very close together. And let's go to Jupiter. It rises around midnight. You can't have mistake because it's very bright and white light. In this screenshot, it's August 8 at 0:30 a.m. And Jupiter will be 3 degrees south of the Moon. Its magnitude will be minus 241. So it's very, very easy to be spotted if you're up late at night. On September 4th, you have a chance to have a good photo op because the Moon in the center, Jupiter to the right, and the Pleiades to the left are in the same field of view. So you can use a DSLR camera to try to spot them. Let's go to Saturn, the star of the month, because on the 27th we reach its opposition and is already visible all night. By the way, this picture To the right, I took a couple of nights ago. It was 1 a.m. in the morning. I was imagining something else, but then Saturn was there and say, why don't you image Saturn as well? And there are also two moons there, Titan and I think Dione. With the rings, Saturn has the same apparent diameter of Jupiter. Without the rings, Saturn is much farther away. While Jupiter is taking 12 years to have a go around the sun, Saturn is taking 29 years. So it's much farther away. And the ring plane tilt is shrinking. In the next slide, I will show what does it mean. So the orbit of Saturn, it's inclined. And what happened, by the way, this is tomorrow night. Saturn and the Moon are very close in the sky together, only 2 degrees apart. Last year, Saturn tilting was much better to spot the rings. This year, 2023, is at 8 degrees. And then in 2025, Saturn will be showing the other side of the rings. They will disappear technically for a few days, except if you have a big telescope, you will still see the rings, like a line. And then you will see the other side of the rings. Uranus. Uranus on August 9 will be close enough to the Moon, Jupiter, and the Pleiades. So if you have a DSLR, take a picture with a high ISO, you can technically spot Uranus in your image. Good luck with that. And Neptune on August 5th will meet the Moon as well. Again, the magnitude of Neptune is 7, so it's not visible to the naked eye. Even Uranus technically is visible from dark sky if you know where to see. And by the way, that's something probably some of you already know. Galileo in 1610, with one of the first telescopes he used, there were Jupiter and Neptune very close together, and he spotted the movement of Neptune, also recorded on his register. And of course, he didn't have a powerful instrument to follow Neptune the next days, but technically he was the person who discovered Neptune. He didn't know that. And then we are already in September. Zodiacal light is the time of the equinox when there is a cone of light. It's not the Milky Way, but you can spot this triangular diffuse globe of light made of interplanetary dust. By the way, it seems like this dust is coming from Mars. And from the northern hemisphere, you will be visible to the east before sunrise, before twilight, but again, you need the dark side to see that. And you can also try to take pictures. This picture was taken from Argentina by Luis Argeric, and that's the link on Flickr. Comets. Not too good for comets. There is one comet that, the comet C2021 T4 Lemon, on July 27, so a few days ago, its magnitude was 8.7. So probably it's a good target for our latitudes, although it's fading rapidly in its magnitude. And there is another comet, a C2023 E1 Atlas, was 9.4 magnitude a few days ago again. And there is another interesting comet that was in the highlights in the next day, a few days ago. 12, it's a P because it's a periodic comet. The Pons Brooks, he had an outburst of 5 magnitude on July 20. Now it's fading, but if you can have a look, although its magnitude is 11.9, so you need a telescope that probably is at least 20 centimeter aperture to take nice pictures. You can try to spot and see if the magnitude is increasing again. It seems like this comet is not new to these outbursts. when it's coming close to the sun. Let's have a look at the sky. I made a map. It's today at 11:30 p.m. There is a moon, and this is spotting to southeast to southwestern horizon. And you can see the summer constellation, the teapot, Sagittarius, at the bottom. Scorpio is almost setting to the right, and of course there is part of the summer triangle. So you see Altair on the top. I will go back to this in a few minutes. And then to the left, there is the moon in Aquarius. Aquarius doesn't have many bright stars, but it's there. If you move to northeast to southeast horizon, you see that the fall constellation are appearing in the middle of the night. So you see Pegasus, the big square, Andromeda, with Andromeda Galaxy, Cassiopeia. Remember the Perseids are just below Cassiopeia. They're starting from there, but don't look directly there. This is where they're coming from when our orbit is meeting this dust. And then when you look northwest to northeast horizon, you see the Ursa Major going down in the sky. And southwestern to northwest horizon, the spring constellation, Bootes, Hercules, are also still high and high in the sky. And I will show something about this constellation in a few minutes again. What can you see for August? So again, the summer triangle, there are 3 stars. They are, the brightest in the summer, and they're Vega, Altair, and Deneb. They look like the same brightness from here, but actually Altair is very close, only 16 light years from here. Vega is 25 light years from here, but Deneb is at 2,600 light years from here. What does it mean? It means that intrinsically, Deneb is much brighter than the other 2 stars. Altair and Vega are very bright because they are very close. You can see the galactic core, Sagittarius, with the beautiful nebula, and they are very beautiful narrowband targets. I will show you them in a few seconds. The Lagoon Nebula and the Trifid Nebula, and they're just stellar nursery. I like this concept that you can see when places where stars are born. And also lots of globular cluster. Specifically, you can see the great globular cluster in Hercules, and also, dying stars, the Ring Nebula, the Dumbbell Nebula, and so on. Our sun, in probably 5 billion years, will pass a phase of red giant. It will expand, and then it will burst into a white dwarf, and then the external layer of the sun will turn into a beautiful nebula. We won't be here. There are also lots of nebula in Cygnus, the North American Nebula, the Crescent Nebula, and of course, the pillars of creation. Who doesn't know the pillar of creation? So the beautiful iconic image from the Hubble Space Telescope, and recently also another infrared image from the James Webb Space Telescope. And there is a picture I took, but I don't want to compare my picture with this space telescopes. And the double cluster in Perseus, because again, this is a place where you can spot the Perseids coming from. Yeah, some picture I took recently, and most of them from my light polluted sky, because if you have a narrowband filter, you're just cutting all the light pollution, and you can take beautiful picture with the right instrument. It was just with the 80mm telescope. So Messier 13, the great globular cluster in Hercules, the Lagoon Nebula, and the Messier 20. Actually, these 2 pictures, I took them from the CEO a couple of weeks ago. The Crescent Nebula in Cygnus, Messier 27, the Dumbbell Nebula, and the North American Nebula. Veil Nebula is the remnant of a supernova, exploded probably 20,000 years ago. The Eagle Nebula, my version. And in Cassiopeia, there is the Heart Nebula. And at the top, there is also the Sol, part of the Sol Nebula. Let's go to the International Space Station. First half of August, no, nothing to see. After 20 August, it will be visible in the morning. There is a website, www.heavens-above.com. You have to specify your coordinates, so longitude and latitude, and you can see where the International Space Station is passing overhead. There are a few in September, so the brightest -3, -4 is the very best option. And in fact, in this image, on August 27, at 4:43 a.m., that's very interesting because from nowhere, the middle of the chart, you will see this bright light appearing from our shadow, the shadow of our planet. And we reach maximum altitude 79 degrees at 4:43 and 44 seconds. And its brightness, can't really see, will be very bright anyways, is August 27, -3.9. So let's have a look and let me know. Space exploration, and then I'm done. There is a Falcon 9. Launch time will be around 12:15 a.m. And also in Falcon 9 Crew 7, it was delayed already. And it seems like this time they will try again on 6:56 a.m. And they will reach the European Space Agency. There is Japanese astronaut and the Russian cosmonaut, and they will go on the International Space Station. Then a few more space exploration spacecraft. There is something in August from the Japanese Space Agency. It's not confirmed yet. And again, there is a Soyuz Progress spacecraft launching later in August. And then something else here. And with that, I think I'm done. Any questions? Thank you so much.
Any questions in the room? Here we are. Okay, perfect.
Thank you. I just want to know a little more about the Perseids. So you said best viewing kind of after midnight. Should I be able to see them before that at all?
Yes, technically, you're always able to see the Perseid, but the fact that the radiant will be very low to the horizon means that you have less chances, because when the radiant is very low, the meteors are coming from, and there is more atmosphere. So it's dimming their brightness. But obviously you can see even when the sky is turning dark, and the sky is turning dark at 11 p.m., pretty much. But every moment is good towards the Perseids, not only after midnight. After midnight, you have more chances.
Very good. Ward, any questions online? No questions online. In the room, any more questions? I have a question for Claudio. Well, first of all, great images that you showed us. Very, very well done. I wanted to ask you, I haven't kept up with imaging filters. A lot of municipalities are now using LED lights. Has the effectiveness of the line filters, H-alpha, for example, decreased because of the LED? Oh.
Of course, when the brightness of the sky is very high, you need to take more sub-exposure to get the same result you can have with less exposure. So generally speaking, I can see that when I take in picture with the narrowband filter from the city, there is a gradient that is grayish. It's more challenging to remove from the final image. But there's all this software you can use. I use in technically PixInsight, and I can try to remove as much as I can. But sometimes when you're removing the background, you're also removing some of the fine details from the nebulosity.
We have a question here. Okay.
Hi, I just wanted to know if the distance from the sun to Earth is getting closer, and is it gradually moving directions?
That's a very good question. I think that over time there are measurements, and I will probably check online, and I will reach out. It looks like all of the orbits are tending to change over time, and as well the inclination of our axis. So it's not always the same. We know that the axis of our planet is moving, spinning. And in fact, so there is an entire spinning in about 25,000 years. And what is today the northern star, the Polaris, won't be the same in 12,000 years. So the star Vega, I talked about before, will be the Polaris in a few thousand years. And same for our orbit. It won't be always the same. Hope this answer your question.
Any more questions? Okay, very good. Thank you, Claudio. We're going to go to fun facts while we change over to the next speaker.
Going south to observe the solar eclipse in April, to drop into Perth Observatory to take a look at that institution while I was making some extra time in that city. The Perth Observatory, like many of the observatories in the old British Empire, are a result of Britain's need to keep its navy in place and have a way of making sure that they knew where they were. So observatories were built at many of the colonies in order to help them with calibrating their clocks when they came into port. And Perth was no exception. While Sydney had already managed to get their observatory in the 1850s, it took until the 1890s for the colony of Western Australia to authorize the building of the observatory. and construction began on Mount Eliza in 1896 and was finished in 1900. And this photograph from the Perth Observatory website is of the government astronomers' residence on Mount Eliza. The principal task at the time was timekeeping, but also the government astronomer was charged with collecting meteorological data and then later seismic data. And it wasn't until well into the 1900s that the observatory began to also do independent research. All the time, it was a government institution under the colonial and then later the state government of Western Australia. Eventually, the site at Mount Eliza became untenable because of light pollution from the city below the observatory site, and it was moved about 23 kilometers to the east to Bickley in 1966, where it continues today. And active research at the observatory ended in 2012. When the observatory was transferred to the Department of Parks and Wildlife from Government Services. During that period from roughly 1900 to 1966, the observatory was quite productive. This listing is from their website, and there are a number of things that they managed to do over the years. Similar to the David Dunlap Observatory, members of their staff participated in eclipse expeditions to confirm Einstein's theory of relativity by doing photographs during and before a solar eclipse to check for displacement of solar images near the sun's limb. They were also involved with doing a lot of cataloging of the stars in the Southern Hemisphere, publishing the meridian catalogs periodically throughout the time of operation. They participated in the International Planetary Program in 1968 with the Lowell Observatory, which netted them a 24-inch telescope. And they also had an astrograph that they had purchased when the observatory was commissioned to do a planetary photographic archive as well, and a number of other things that they also managed to do. The amazing thing about this, when I look back into the records of the Perth Observatory, is that this was all done by 3 people, including maintenance of the observatory. So they were busy. They also did outreach. There's very little mentioned about outreach activities at the Mount Eliza site, although there is this statement from the 3rd government astronomer about the sky conditions at Mount Eliza. And I'd like you to particularly look at the last 3 lines of that passage, where he talks about the conditions and how they could not possibly adversely affect observing conditions on the site. Of course, you know, this is typical. And by 1966, the light pollution was so bad that they ended up having to move. So in relative terms, thanks to Google Maps, here's the 2 locations. You'll note that the Mount Eliza site is really nice because it overlooks the port of Fremantle, which is a saltwater port. This is where all the ships came in from India, and today it's still a very busy container port. It's the only port on the west coast of Australia, and it's also where all the cruise ships come in. So Fremantle continues to be very busy. And the tower that you saw on the earlier slide, I believe had a time ball on it. They also did daily time cannon shots as well. With the move to Bickley, they began to revive the public outreach activities by offering public tours of the observatory. And this continued until the observatory's research activities were wound down in 2012, and the astronomers were let go. As with the Dunlap Observatory, they did have a group of enthusiastic amateurs who helped support the outreach program during the time at Bickley. And it was the Perth Observatory volunteer group who, very much like we did, signed an agreement with the Western Australia government to actually take over the management of the observatory. And today, they have 3 part-time staff and about 120 volunteers who run a very, very active education program on the site now. I visited there on the 14th of April, and a colleague of mine who works at the University of Western Australia picked me up from my hotel. We had lunch out in the area close to the observatory and then drove up there to meet our hosts at the site. This is the visitor reception and administration building, which is the original 1966 administration building. It's now been turned into a media building as well as administrative center for the observatory. They have a lovely museum with some of the old artifacts and instruments from the early days of the observatory there. They have an extensive library, the technical publications and books and so on from establishment in 1898. They also have a small souvenir shop as well. Out back is a small garden, and this sundial from the original Mount Eliza site is set up, and you can take a look and at the analemma with this sundial. Out beyond is the telescope park, and this is a very extensive area. You can see that they have 7 domes and roll-off buildings there, including that elevated one at the back, which is where the Perth Lowell telescope has to be located. So that's the 24-inch Bowler and Chivens telescope, which is very similar in design to the instrument that's down on the U of T St. George campus on the top of the physics tower. In addition, they have the 13-inch astrograph, a 12.5-inch Newtonian reflector dating from 1919 is in one of the other buildings. The largest instrument they have is a 30-inch Obsession, and they've got a number of other LX200s that are in the moderate aperture range from 30 and 24 inches, plus additional telescopes, 14-inch, 12-inch, 10-inch telescopes, and so on, plus some smaller refractors and Coronado H-alpha scopes. So they're very, very well equipped to deal with a large visitor group. This is the astrograph, which has pretty much all of its original fittings in it and is available for observations as well. In the main building is the original instrument, which is the Transit Circle Meridian, built in 1898, a 6-inch refractor on the meridian wheel. Of course, the idea here is that it moves up and down in azimuth so that you can get to different declinations. And as stars go by, you can mark their passage across the meridian and map them that way. It was refurbished in the 1960s after many decades of hard use, but was never used after the move to Bickley. The Perth Lowell telescope is at the top of this 3-story tower, supported on 4 massive concrete pillars, and then there's a huge concrete pier extending from the bedrock below up to the dome. It does stay steady, and this telescope was originally used for the International Planetary Patrol and is still used for some imaging now. I didn't bother to climb up. it was a hot day. And I wasn't really relishing the thought of putting my knees through that set of steps all the way to the top. But people do get up there to actually use the telescope. It's not a remote access instrument at all. They also have some radio astronomy demonstrated here, and they have an element from one of the major radio telescope systems on display, and it actually is hooked up and collecting data, although since it's only about a 4-meter square array, it doesn't have a great deal of resolution, but it's good to pick up solar activity as well as occasionally some transmissions from Jupiter as well. They have a really impressive display for Aboriginal astronomy. The local Aboriginal population has been around for about 60,000 years, they figure, and the World Wangkini or Sky Stories display is where they put on programs that talk about the Aboriginal cosmology, and the paintings on the inside of the structure were done by a number of local Aboriginal artists as well as art students of Aboriginal descent at a local high school. And this was paid for through the Lottery West Community Grant Program in 2018-2019. The walls are from a telescope dome that was never completed. And so they are semicircular, and these paintings really look lovely in the daytime. The website shows this photograph of it at night, and through the doorway, you can see the red lighting of the entry to the telescope dome, and that was paid for by, I believe it was the Lions International or Kiwanis International Club in Perth. But again, this is very, very well used to teach the public about Aboriginal astronomy. So the tour was about 2 hours, and they were very generous with their time to take me and my driver, Dr. Hoskin, around the place. It turned out that Arthur, the senior volunteer on our tour, had actually visited the Dunlap Observatory. And when he found out that I was coming to visit, he especially asked to take me around, which was really, really nice. And so in addition to talking about the Perth Observatory, Arthur and I were exchanging notes about managing a publicly owned observatory and, you know, running a program driven fully by volunteers. So it turned out to be a busman's holiday visit for me, in the sense that I was able to have some very, very interesting discussions with him. And I do want to thank both Arthur and Michelle, our hosts, and Matt Woods, the tour administrator, who made the arrangements for me and Dr. Hoskin to the tour. So that in capsule is the Perth Observatory. If you're ever down there, it's a very pleasant drive out into the countryside, and it is well worth the visit. And if you can get in there on one of their public nights to see their programs, and there are many of those, it's well worth the visit. Okay, thank you very much.
Thank you very much, Ralph. Do we have questions? Any questions in the room? No? Online? No questions online either.
Great.
Okay, thank you very much, Ralph, for sharing your adventure with us. All right, so we're going to go to fun facts for a moment while we switch laptops to our next speaker. That's Frank Dempsey, and he'll talk to us about smoke and forecasting it and how it impacts observing.
Okay, sound good here? I'll stand right about here then. All set to go? Is that a go ahead, Paul? Okay. Okay, well, good evening. And so you see the title. Fortunately, Paul mentioned earlier that it relates to astronomical observing. I didn't really put that in the title. And so, of course, I'm here all the time to encourage enjoyment of astronomical observing. And so this smoke forecasting relates to trying to observe the sky through the smoke. I set up a few little subjects set up as a sort of an outline, and so why do I care, and a few resources to use, and a couple of examples, and has it ever happened before, and then a quick summary, and we'll be done. And so who cares? And so it matters when the transparency of the sky becomes really poor, and so a cloudless daytime sky becomes white instead of blue. And so coincidentally or not, today was a very good example of this. You may have noticed the sky this morning was blue, as in the picture in the bottom. I try to put pictures on most of the slides so I don't throw up a slide full of text and nothing, so I put up a pretty picture sort of thing. That's the idea there. So anyway, the point about today was it got cloudy, and then you may or may not have noticed it cleared up this afternoon, became less clouds, but a big layer of smoke moved over us this afternoon. So the sky transitioned from blue this morning to white with smoke cover this afternoon. So today happens to be a very good example, coincidentally. But the point about trying to observe through it is that we can observe some stars, diminished brightness of stars and planets pretty well, and the moon, and some other things like stellar objects like open clusters and maybe globular clusters. But for faint extended objects, forget it. It means that trying to observe, say, a 12th magnitude galaxy, it's a faint fuzzy through a smoky sky is really much more of a challenge than when you have a transparent sky. So it's quite a observing challenge when you have some smoke in the way. A few resources. The resources I want to really promote are observing. A few observations you can make yourself, and combine them with some model data, which you may or may not want to access. But just look at the sky and see is it blue or white. And as I mentioned, today is a very good example. And the other observations to use are visible satellite imagery, which I'll point out in a few examples. As for the forecast models, I'll point them out as well, but they are pretty handy and they can be useful, but they do have some limitations. They are far from perfect. So here's an example of satellite imagery. And so this particular example, hopefully you can see, I can barely see from here with floodlights in my eyes, but you can probably see Lake Ontario split by generally blackness or clear sky to the west of central Lake Ontario, and a big, huge, hazy cloud of smoke covering eastern Lake Ontario and most of the state of New York and eastern Ontario. You may even pick out a spot near Lake Huron that's also covered in smoke. This is an example a few years ago, but it's a very good example. And so it's just one example of many that I've been compiling, but if I had it on a loop too, you'd see the smoke very gradually moving eastward. But anyway, it's just one example. Here's another example, a bit different, because this is a case where it's mostly smokeless. This is an example of a forest fire in Killarney Provincial Park. And so anybody know where Killarney is? Or anybody not know where Killarney is? Some hands are up. Okay, good. So you see it at northern Lake, northern Georgian Bay, approximately near the center of the image. And you see a streak of smoke extending from left to right. So this is a case of a very local forest fire and a very local plume of smoke extending eastward from the fire. So we can pick this out too on visible satellite imagery. So this is the sort of resource that I want you to use if you want to forecast smoke. See it, find out where it is. Don't rely totally on computer models which may or may not pick it up because they have limitations. And so look at the satellite imagery, separate cloud from smoke. So that's really one of my main points here. The other point is to use, you can, if you want, use modeling. So computer modeling exists in a few examples. This particular example is Environment Canada's model. So I just threw up a web page. I wasn't going to work through too many details of how to get to it, but if you want to pull up your weather forecast page, I left most of the URLs on here, hopefully. So if you really want to see it, you see it at the top, weather.gc.ca. And on that page, you look for analysis and modeling, and at the bottom, you see modeling. I put the arrow to mark off where it marks off their model for smoke forecasting. When you click on that, Then you click on evening forecast or morning forecast. It's updated twice per day. So you click on that and then you get an image sort of like this. So you see at the bottom, there's a loop, maybe a 72-hour loop, so you can pick one, but I just picked one example, and coincidentally, it's quite recent. It's yesterday, actually. The fact is, I had a few examples set up, and I decided a couple days ago that we had a really, really good example coming up next couple days, including yesterday. So yesterday's model lines up really well with what's on the satellite imagery and what's coincidentally overhead right now. But anyway, the point is, it's an example of a computer model forecast you can get for PM 2.5 total column, as it's called. But anyway, you scroll around at the bottom, you can find some links for some zoomed in images. In this case, the Ontario regional chart. So a bit of a zoomed in image. May give you a bit more information, may not. Anyway, that's one of the models. Another one is one that started off as a few years ago, a decade ago actually, as Blue Sky forecast model in U.S. Forestry Service, and UBC got a hold of it, and it's now called Fire Smoke Canada. So firesmoke.ca is a website. If you click on that, I marked off the arrow to the website spot on the button for the view forecast. So when you click on that button, you can get another 48 or 72 hour, whichever it is, loop. I think it's 60 hours. But anyway, the point is a loop hour by hour of smoke moving across the country. It's a little bit different from the previous one I showed you because this is intended to show PM 2.5, or which is fine particulate matter of 2.5 micron. It's so-called respirable particulate at ground level, affecting ground level air quality. That's what it's intended to show. So it's a little bit different from previous chart I showed, which was total column particulate. Point is, anyway, it's a pretty good map. It's pretty good a lot of the time for showing where your smoke moves across the country or across the continent. You see all those red spots are marking off hot spots, and if you zoom in, I think I put a zoom in image here. Did I? No, I did not. I took it out. So anyway, you can zoom in for more detailed hotspot data. So if you were to zoom in on any particular area, mousey may not work here, but zoom in on any particular area, you'd get a cluster of more hotspots. So that's a reasonable way that they've packaged it together into this website image. But anyway, you can see with increasing intensity where the plumes are more intense. And so anyway, the other one I wanted to mention was the website called astrospheric.com. I noticed a lot of people use this, a lot of amateur astronomers use this, and it's fine, but it has limitations. It's not 100% perfect for sure. But when you pull this one up, it has, I marked off with an arrow, again, a spot you can click on. It mentions layers. And if you click on that, you can click on smoke, and this will come up. And this is a smoke map. And so it's pretty good. As I mentioned, it's maybe a little bit overdone, but it doesn't appear quite that intensely on a satellite image. But it's just a good way of giving a rendition of where the smoke is. And so range of intensity scales. So that's a very good product to use, is that astrospheric.com. Not perfect, but very good. Okay, that's one of the main resources I wanted to mention were the observations, where you observe with your eye and satellite imagery and pick out what you see and decide where the smoke is, as well as forecast models on computers. Their websites, I just showed you a few. There's some other resources you can access. Where are the fire hotspots? The NOAA smoke analysis, air quality maps, ground-based observations. So there's quite a lot of information that you can go into if you really want to. There's quite an extensive list of resources online. I just wanted to mention several, and here's one recent example of Natural Resources Canada's hotspots map. This is updated constantly, and so you see, for example, here there's quite a lot of fires burning across the continent, and that's typical in springtime, although this year is not quite typical. It's far worse than typical. But anyway, hotspots map gives you some idea of where a lot of fires are. For if you pick out, for instance, northern Alberta, northern Saskatchewan, southern Northwest Territories, you might guess there'll be a lot of smoke drifting downwind from there. Of course, that's what's happening. Anyway, hotspots map. What else did I put in here? Well, the NOAA analysis, U.S. National Oceanic and Atmospheric Administration, NOAA, puts out this hazard mapping system, fire and smoke product, and some other products as well, text products and some others. But the point is here, at a glance, it's a nice image, nice pretty picture of where smoke is. based on humans looking at it and putting out this analysis map. So you might find that helpful too. I think this is also a fairly recent one, and you see, once again, I mentioned this plume of smoke that was on the model imagery that I showed a few minutes ago that is coincidentally over us right now. So anyway, analysis map. So here's a really extensive, didn't want to go into this too much because there's a huge amount of information on this. If you click on worldview.earthdata.nasa.gov, this particular picture is a satellite image patched together in segments, of course, of North America. Big plume of smoke across Northern Ontario. You can pick out numerous layers from hotspots to PM 2.5 to a whole range of things related just to fire, not to mention a lot of other so-called satellite remote sensing parameters that are measured daily and hourly and available for research or for public use if you want to. So it's a huge amount of information on this. Didn't want to go too far into it. So that's just another resource anyway. You can, another resource you could use if you really want to is weather forecast charts. And so for instance, if you pick out some upper level winds and plot a map for that, and left a URL sort of here visible here if you really want to look at it. Didn't want to say too much about it. Of course, using weather maps can be very, very helpful, but I know that weather forecasters don't have a really good reputation and don't really go around bragging about being meteorologists or forecasters, and can get tomatoes and eggs thrown at them and so on. So I didn't want to get too far into this. So just want to mention it. It is a resource if you want to use it to help you forecast where the smoke that you see on a satellite image may be going. So let's see. I wanted to point out a detail here that the forecast products from computers can sometimes be unrealistically too detailed. And so you see an example here on Astrospheric, and I've occasionally looked at this and wondered what the heck's going on here, and is that realistic, and is that what I see moving overhead in the next few hours? And so I'll tell you, you can occasionally pick out some conditions where plumes of smoke get diminished, where holes appear in them. For instance, following a big thunderstorm cell, the back edge of it can have a lot of subsidence, and it can really dry out the clouds. So you can see a cloud deck and then it being clear in a big spot behind the thunderstorm cell that's moving eastward. And occasionally I've seen the smoke diminish too. So you can pick out a big hole appear in the smoke deck behind it. So I can sort of understand, or once in a while at least, appreciate that the smoke diminishes in some spots, but I don't think I've ever seen it increase in intensity unless there's a fire at that particular spot causing increasing smoke. And that's possible too with thunderstorms. Lightning is the main cause for forest fires, wildfires, and so yes, it can happen, but in a lot of cases I've looked at it and wondered what the heck's going on here, and it's not quite totally realistic. So all I would say here is please be careful if you look at these computer models. So I wanted to point that out. Had a couple of examples. June was interesting this year because smoke was not only clogging up our skies and making deep sky viewing pretty difficult and challenging, but we had a lot of ground level air quality mess in the Toronto area, as well as across Ontario, as across eastern North America, where that smoke came down and caused significant air pollution episodes. But that's not the point of the talk here. So the point was here, I showed a couple of examples of products you can use, and showed you the analysis chart earlier. A big plume of thicker smoke across, central part of the continent, Great Lakes area, and so on, and showed up here in this particular forecast chart, a pretty big mess across southern Ontario, and that was pretty significant in June, various days in June. In fact, most of the month of June. But the other example I pointed out was I reset this presentation up a couple days ago when I realized this is a really good example coming that was really obvious and probably would still be in effect by the time I do this presentation, which means right now, today. So you see a couple of days ago, the satellite image showed really distinct, huge smoke plume moving southward across northern Ontario. You may have noticed it also on the Earth view image I showed, but anyway, the point here is it shows up really well in the satellite imagery. And a couple other products I put in here. So the forecast computer model shows it pretty distinctly. Big mess of smoke. This computer model also showed it pretty distinctly. I might have showed this one earlier, may not have, but anyway, so various products all show a similar thing. And the point here was that point that affects us right now is that this plume moves southward very slowly, and now it's moving eastward across southern Ontario. So that if you notice this afternoon, I may have mentioned this afternoon, the clouds cleared a little bit, and we were left with a very smoky sky as this plume moved eastward. So I decided a couple of days ago, this is a really good example to show. Okay, did I set up third example? I think I took it out. The wind forecast chart, I said I didn't want to dwell on weather forecast products too much. And get, I'll get bricks and tomatoes thrown at me, but point of the upper winds chart is you see northerly winds from mostly the north, northwest, flowing from northern Ontario down towards southern Ontario. So, so forecast charts can help you out if you want to look in more detail. Wanted to finish off with some longer term forecasts, and there are numerous products online from Canada and USA, huge country to our south, puts out a lot of products, but just from Natural Resources Canada, here's a monthly chart for showing fire intensity, severity, and it's not looking pretty for this month of August. So I wouldn't want to dwell on it too much. So let's look at another product for temperature. Temperature forecast for the next 3 months. It's not looking too pretty either, unless you like nice warm autumns. So, but the point of temperature is that it's one of the factors affecting fire severity. So that if you have a pretty warm summer, as we have right now, and it happens to be dry in the forest areas that tend to be forest fire smoke sources, then watch out. It could be a pretty bad year. And that is a pretty bad year. Did I throw in one more resource? Yeah, seasonal forecasts. I didn't want to mention too much about ENSO and the El Nino, but if you have an El Nino situation that encourages Western Canada dryness and warmth, then watch out even more for more fire activity. So if you get a La Nina phase coming in eventually, that can help cool things down a little bit. But this is showing El Nino, and it's a warm phase, and so case to watch out. But I didn't want to say too much about it. Just say that there are a lot of resources you can look into related to weather and climate. Lots of others too. Watch out for blocking situations, blocking ridges over North America, especially in springtime. Also a good case for more active fire season across Western and Central Canada and USA. So a lot of resources, didn't want to say too much about them. Let's see, I wanted to finish off with saying, has this happened before? Yes. So these are pictures, analysis pictures I saved from, I think it was about 10 years ago, maybe. Yeah, 2000, no. Oh, this is 2021. So, but anyway, you see numerous times per year, I've captured these images, saved them for various purposes. I think I had another one, 2008 here. So each year for the past 20 years, I've noticed things. This is just one example that I had. This is in a paper I published when I was employed doing this stuff, but carbon monoxide measured satellite supported this picture of a plume of smoke from source regions down towards southern Ontario, marked off by the carbon monoxide signature measured by our satellite remote sensing techniques. But anyway, that's just one example of a lot of information that's available if you want to look at it. It has happened, been ongoing for quite a long time. So to finish off with, here's a 2010 example. As I said, I wanted to put in a pretty picture just to break up some pages of text, which is pretty boring, really, of course, without a picture on it. Anyway, trends. I'd claim that it's we have a worsening number of smoke episodes during the past decade just by looking at the sky, saying the sky is messed up and it's really messing up our observations, and it's been worsening during the past decade. And I'd say in the past half century, it used to be a rare situation. I remember, 30 or 40 years ago, but in the past 5 years, it's less and less rare. It's quite common. And this year is way off the charts in terms of severity. And this is, I put subjective observation. That's just my opinion as a sky observer, but that's strongly backed up by fire statistics. So fire stats are much worse this year than have ever been in the record for Canada and USA fire monitoring in terms of hectares burned, number of fires, earliest in the year it's begun. Has happened in past years, in the past 50 years, yes, for sure, but this year is by far the worst ever in record. So it's not just my subjective observation. It's not just my eyes getting, say, cataracts or whatever, causing it to be more cloudy or whatever. It's backed up by fire stats that are showing that this is a pretty bad year. So I think I finished off here. I just wanted to summarize. You can forecast this stuff by a combination of observation, satellite imagery, and your eyes looking at the sky, combined with model output guidance. If you want to look at models or other products too, you can combine these together and come up with your forecasts. And I'll have to admit, looking at Astrospheric this year, it is quite a good product too. If you want one single source that's pretty good most of the time, it's also a very good source. Okay, so that's all I set up to show you. We're all done, Paul, and any questions, I'll be glad to answer them.
Thank you, Frank. Any questions? Right here. Okay.
Looks like Ed has
a couple. Very good.
So typically, I find that, or we used to find that winds from the northwest would really clear out the skies and you get lovely transparent skies and you get great deep sky views. And whereas if it's coming from, say, the southwest, you get a lot of humidity and it gets kind of murky. Now with all the forest fires, is there any wind that does us any good, or are we just going to have to wait for the fires to go to get transparency?
Good question, because this year has been a case of winds from all directions causing trouble. So you're right. In the case of a smokeless sky, north winds usually bring very dry air from the north, very clean, dry air, good for air quality to breathe air, and very good for very deep blue, transparent skies, which helps us out at night. And it used to be that when we get a southwest wind, it was increasing humidity and we expect more haziness. However, this year, a lot of smoke comes from the north. We've had cases where smoke plume has gone to our southwest, and then when the wind has become from the southwest, it blew the smoke plume over us. Sort of happened today with the west wind. The big smoke plume last couple of days came down to our west. Thought it was going to hang around there over across southern Ontario and Michigan and maybe not bother us, but it came, then it drifted eastward over us right now. The worst case was in June. So far, the worst case was in June when we had northeast, when air quality was okay, we didn't have too much smoke, but forest fires over Quebec caused a lot of smoke, affected the Ottawa area. And it didn't affect us until a good northeast wind came. Now, I always say the best observing skies come with a northeast wind. That's because we have a low pressure area to our south, high pressure to our north. The wind flow is from northeast, and that brings the driest, clearest, cleanest air across Ontario for the very best observing conditions. You don't even need to worry about dew on that situation because it's very dry air. So low humidity, clear sky, very transparent air when we have northeast winds most of the time. But this year in June, northeast winds brought us the worst air quality ever and measured in southern Ontario in about 20 years of measuring it. And many cities across eastern USA as well. But northeast winds, bad luck. Southwest, pretty bad. Northwest winds, pretty bad. Have we had any bad cases from the southeast? Not really. But of course, when we have a southeast wind, it's usually ahead of a low pressure area and you have increasing cloud. So to answer your question, it's a good question because it means that hadn't thought of it that way, but we've had a bad smoke episodes from all directions this year. So it's been worse every year in that case too. So good question.
Okay, we have a question here.
It's a quick question. The resources that you mentioned earlier, do you know if there's a lag in between what is happening and if I were to observe it now, what's the time period lag in that?
Yes, there is a slight lag because one example is a daily analysis that I showed is put out sometime around mid-morning, and it's caused by analysts. Maybe they start at 7 or 8 o'clock in the morning. It takes a couple hours to put a chart together and put it on the website. But yes, it's a little bit late by the time you see it. However, smoke tends not to move too much in a few hours. So smoke generally moves in one day fairly distinguishable amount unless you have really strong, powerful winds like in a jet stream, which does happen. Generally that lag that does exist doesn't affect us. Or in other words, the products are still quite good. And so the forecast products by the computer models are still valid. They don't tend to get out of date. They're still pretty good. The analysis products are pretty good. So the answer is it's not really a problem. But as I mentioned, that's why observing using satellite imagery, looking at the actual satellite image is a very good technique to develop as well. Just so you keep an eye on what's happening where, and if the analysis charts are a little late or a little out of kilter with what's actually happening. But in my experience, I've looked at them every day for decades. It's not really a problem. Okay, any other questions?
Okay, Frank, we've got a couple of questions online here. First one from Lewis. How does smoke affect the high altitude observatories other than Canada, like those in California, the Alps, Hawaii, etc.?
Well, it's easy to answer with Hawaii. I'm not aware of any forest fire sources upstream of Hawaii. I'd have to say I've never heard of any problem affecting California. A few years ago, Oregon was heavily hit by, and Oregon is a fairly high desert. Part of Oregon is a fairly high desert, and they were affected badly by Canadian forest fire smoke that moves southward quite a lot. So the more general answer to your question is it's quite possible for high altitude to be affected by it. So one detail about the weather chart I showed was I showed it as 850 millibar level, which is about 3 kilometers height. This often turns out to be a reasonable transport level as one way to word it for. It matches up with the movement of the smoke with the winds that you see in a forecast chart. However, 850 millibar often isn't quite the right height. Sometimes 700 millibar, sometimes 500 millibar is a better chart to use, and it's about 18,000 feet. So it's much higher in the atmosphere. And it's better, matches up better with where the smoke is. So it indicates the smoke is very high altitude. So that's why I say that high altitude smoke can exist and it can affect observatories. We don't hear about it too often from California and those big Western observatories because they're mostly upwind of most of the smoke sources. Bit of a change a few years ago, maybe it was 5 years ago, huge fires in Yosemite Park up in the California mountains and elsewhere. But and California does get a lot of wildfires too, but it probably is a case of it being mostly upwind of most of the sources. So that most of the sources being across central part of North America, such as right now across northern Canada and northern Alberta and Saskatchewan, bad source right now that affected eastern USA. Occasionally, some years it's been a bad fire situation in areas further east of California, including Colorado and Arizona and New Mexico. But I think the main reason why the major observatories in California don't get affected by it too often is because they're upwind of most of the potential smoke sources. But this smoke can be high enough to affect high altitude observatories, yes.
Great. We got one question from Victor Aoyong. I hope I pronounced that right. Does light fire smoke negatively affect the mirrors for those with reflector or catadioptric telescopes?
I couldn't quite get that. Could you repeat that?
Does light fire smoke negatively affect the mirrors for those with reflector or catadioptric telescopes? Sorry.
So I think the question is referring to ground level smoke. That's how I would interpret it. So yes, corrector plates on the front. Yes, I would say my opinion, since I have numerous telescopes that use front end corrector plates, I would say no, because by the time the smoke, local light smoke is thick enough to affect the your corrector plate, you're choking in smoke. That's my impression. That's my impression. And furthermore, the regular air pollution that deposits with dew on the corrector plate is worse. It'll affect it far more often than any smoke. So that's my impression.
Okay. Excellent answer. Eric Briggs wanted to know if you had mentioned the blue sun phenomenon from September 1950 due to wildfire smoke.
I didn't mention a lot of famous cases of smoke, historical smoke episodes. Didn't want to mention them. One interesting point about Eric's comment is the blue moon. I think it was briefly mentioned earlier about the blue moon being the not only the second full moon in a month, but also being caused by wildfire smoke traditionally in the summertime. But drifting away from Eric's question, I think it was again. Did I mention it or make note of it? Well, the point was there have been episodes in the past where smoke has been so bad caused a blue moon, but it's far better known for causing diminished sunrises and sunsets. Not only red, but gray. You know, when the sunset in a cloudless sky is gray rather than not even red. So yes, blue moon, yes, but it's more noticeable in other cases, like the sunset and brown or gray colored clear sky.
Thanks. Just curious, how long does the smoke persist after the source is extinguished? And is there a difference between the gaseous and the particulate components?
Yes, very interesting question about atmospheric chemistry and also about dispersion of plumes. I would say that regarding the length, the duration of the smoke after leaves the fire, it persists for approximately a week. So if a fire goes out, and fires do go out because of heavy rainfall events that extinguish major forest fire events, and say, take your pick, northern Alberta or some area upwind of us, where there's a big cluster of storms, it gets extinguished by heavy rainfall. That smoke can persist for about a week, depending on the winds. So if it's really strong winds in just the right direction, they can blow it out toward, and Europe complains about it, and a few days later. But there can be light winds where we're well south of the jet stream, or the jet stream is too far north. And so we just have light winds, and so that the smoke plume drifts around, persists around. This is the problem in the middle of summer too, but the smoke plume doesn't really move very fast, and you see it on, you observe it on your satellite imagery as just drifting around and partially breaking up and taking its sweet time to go anywhere, and it's a nuisance for generally a week afterwards. As for transformations, yes, it's a huge subject. Where should I start about chemical transformations? There's oxidants, there's heavy particulate, there are lighter components of the smoke that drift out or react earlier. So a lot of things can change. A lot of things can change to more acidic components of the smoke that can get more dissolved in moisture and rain out, where other components are more inorganic and they tend to persist longer because they don't react chemically. So chemical transformations, very interesting subject. I would just say that some components of the fire, depending on, I should mention there's crown fires, and there are fires that are burned from the base of the trees, and there are ground fires where the fire is on the ground that put different components into the smoke, goes into the atmosphere. So anyway, a smoke plume is composed of a lot of different components, some of which react and can become acidic and more prone to dissolving in water and getting washed out and removed, and others are more inorganic and more inert and don't transform or move or get washed out. So big subject, but the bottom line is it's a big mixture of components, that some of which get removed quickly and some don't. So I guess I'll leave it at that.
Okay. Frank, I have a two-part question myself. Say you're looking at a visible light satellite image. Can you tell the difference between smoke and regular haze? And does it matter when it comes to visual observing whether it's smoke or haze?
The second question is easier to answer because it doesn't matter. Smoke or haze doesn't matter because low-level haze is going nowhere generally. So if you're out for a few hours in an otherwise clear night, it doesn't matter. Your views of, say, deep sky objects are messed up, whether it's smoke or haze. The first question was, can you tell? So one thing I took out here to try to shorten the presentation was a satellite image loop. And the one I had was from a couple of weeks ago. It was from June, actually, where if I showed a loop, click on the movie. Now, it's a good way to mess up a presentation and say, why the heck isn't this working and why doesn't it work? And even with floodlights in my eyes, I probably wouldn't be able to tell, and it wouldn't be a very good presentation subject. But if I did a loop of satellite imagery, you'd see, for instance, this huge plume across eastern Ontario would be moving very slowly. You'd be able to pick out these cumulus clouds. I can't really get control with mousey here, but there it is there. Maybe I can. You'd see these cumulus clouds coming and going and popping up and going down, and you'd see mid-level clouds like these ones up here gradually scooting through, and the smoke would be easier to see. And with some practice, the answer to your question is you can distinguish it easily from cirrus cloud. So cirrus cloud moves in bands generally with jet stream speeds. The smoke plumes are generally lower than the jet stream, and you see them persisting longer, especially when you stay on the correct image. But so the short answer, yes, with an image loop of a couple of hours, you can easily pick out smoke, and that's why I say if you want to observe it, develop this technique. It doesn't take much practice. It becomes obvious after a little while, especially these days. This past month with a lot of examples of smoke in the air, where sky is clear otherwise, you can see smoke moving, and so yes, you can pick it out. The trickier thing might be picking out, confusing it in the morning with ground level fog. So you see this big plume across eastern Ontario. You could say it's that's what ground level fog looks like in the morning. Now, I deliberately put in afternoon images. So these are 21 Zulu is about 5 p.m. Eastern Daylight Time in the afternoon. So afternoon image, morning fog is long gone. But if you look early enough in the morning, you can pick out fog that looks fairly similar to the smoke and doesn't really move anywhere. But yet by afternoon, that is definitely a smoke plume, and you can distinguish it from mid-level clouds, low-level clouds, and high-level clouds with a little bit of practice.
All right. Any more questions? Good. Thank you very much, Frank. All right. So thank you to all our presenters. Great presentations this evening, as usual. That concludes the speakers lineup. I'll call on Tom Luton to take care of the announcements for tonight. First, we're going to go to fun facts to switch over computer, I suppose.
All right, well, good evening, everybody, and thank you very much for joining us, both here in person and online. My name's Tom Luton. I'm the president of the Toronto Centre, and let's get on with the evening's announcements. So we've got two types of meetings, both online and here at the Ontario Science Centre. You've just seen one of our recreational astronomy nights, and coming up in September, we'll be starting our next season of speakers nights. That's where we're going to have a professional member of the astronomical community come on in and tell us about what they're working on. So for those of you who are watching us live on YouTube, please say hello in the chat. Enter some questions for presenters as others have done. If you're a new member, introduce yourself. And if you come to us from far, far away, please let us know where you're from. So our next recreational astronomy night is on the 6th of September, 7:30 p.m. At last talk, we had still a TBA for the sky this month. Paul, is there any update on that matter?
Yes.
Andy Beaton will be doing the sky this month. And then Ralph Chou will be back with Down Under for a solar eclipse. And then Dan Falk will be talking about In the Footsteps of Edmund Halley, online and here at the Science Center. Oh, and if you got something you'd like to present, please contact Paul Markov. So, as I said, our Speakers Nights next season will begin in September. So, coming up here at the Science Center on the 5th of August, that's this Saturday, 10 a.m. to 12 p.m., we have solar observing going on right outside of right in front of the building. This is weather dependent, so we will be posting a go or no-go call on the website. On Friday, the 25th of August, from 7 p.m. to midnight, we will be having another one of our famous Millennium Square public stargazing sessions. That's Millennium Square in Pickering at the south end of Liverpool Road. Just a reminder that it's cooler down by the lake, so please dress accordingly. And we are still recommending folks wearing masks. Please check our website for a go, no-go decision based on the weather. So coming up at the DDO in the next few weeks, we have 2 sessions of Astronomy Family Night on Saturday, August the 5th, 9:30 to 11:30 p.m. and on Sunday, August the 20th from 8:30 p.m. to 10:30 p.m. You can register for the events online. Links can be found at rascto.ca. Coming up also on the 26th of August on Saturday from 1 p.m. to 2:30 p.m. and from 2:45 to 4:15 p.m. is DDO Planetarium Day. There's a registration fee for this one as well, and as well, the links for registration are at rascto.ca. And then that night, August 26th from 8:30 p.m. to 10:30 p.m., Dr. Marios Galanis, my apologies, will be discussing building a telescope the size of the Earth. For reference, our DDO telescope is 74 inches. Again, fees and registration links are at rascto.ca. And then we have on Sunday, August the 27th, from 12:30 to 1 p.m. is Sunday sun gazing. And then wrapping up the month at the DDO is Stargazing Night, the first clear night of the week of August 28th to September 1st. First clear night, so it's a single night event, just whichever night that the weather decides to behave. No registration required, just walk on in, bring your own binoculars. So, observing sessions for members. So we are running our Long Branch Park pilot project again. The first clear night of either August 19th or 20th, 8 p.m. to 11 p.m. This is a pilot project to see if Long Branch Park is a suitable location to be one of our City Star Party locations. Again, check our website for a go, no-go decision based on the weather. And then our regular City Star party is at Baby Village Park on the first clear night of August 21st to 24th, except Wednesday. So the first clear night of the 21st, 22nd, or 24th, Monday, Tuesday, or Thursday, 8 p.m. to 11 p.m. Again, go or no-go decision is on the website. Up at the CAO, operations are largely back to pre-pandemic conditions with a few exceptions. The main one being that the only 2 unrelated persons per bedroom can book a bedroom and mutually agree to share that room. And masking in common areas is encouraged, but whatever folks are comfortable with in attendance can go ahead. We've got public outreach events and supervised weekends when the moon is not up in the sky for the summer and fall. Please take a look at the CAO bookings page for details and read everything before you make your decision. Wanted to just a reminder that Adrian Aberdeen stepped down as treasurer and has been replaced by Dennis Cray. One final call for a volunteer badge for anyone who is a longtime person who's been working and needs a new badge because it's been a few years since we had of these badges made. This is the last call. Please drop me a note, president@raskto.ca. We're also looking to fill a few spots on the job board. We're still trying to find education and public outreach chair, as well as a volunteer committee chair and a marketing committee chair. And the EPO is always looking for additional members to help out, especially the online presenters and telescope camera operators. Reminder that to volunteer, you have to be a member. So drop me a line, president@raskto.ca. You can renew or sign up online for RASK membership at secure.rask.ca. Gift memberships are also available. Please speak to the national office, membhub@rask.ca. For some, this is the most important part of the evening. The meeting after the meeting, I'd like to invite anyone here in person to join us at the Granite Brew Pub, 245 Eglinton Avenue East, to plug that into whichever form of software you need to navigate. Free underground parking, which is accessible off of Mount Pleasant. We're usually in the front. And for everyone else, thank you very much for joining us tonight. Please follow us on all the forms of social media that we've got listed here. If you've liked what you've seen on YouTube, please like and subscribe, click the notification bell. Be safe and keep looking up. Good night, everyone.